New research suggests that the first dinosaurs laid soft-shelled eggs, a finding that contradicts established thought. The study, led by the American Museum of Natural History and Yale University and published today in the journal Nature, applied a suite of sophisticated geochemical methods to analyze the eggs of two vastly different non-avian dinosaurs and found that they resembled those of turtles in their micro. The research also suggests that hard-shelled eggs evolved at least 3 times independently in the dinosaur family tree. The assumption has always been that the ancestral dinosaur egg was hard-shelled, said lead author Mark Norell, chair and Macaulay Curator in the museum's division of Paleontology. Over the last 20 years, we've found dinosaur eggs around the world. But for the most part, they only represent 3 groups: theropod dinosaurs, which includes modern birds, advanced hadrosaurs like the duck-billed dinosaurs, and advanced sauropods, the long-necked dinosaurs. My guess, and what we ended up proving through this study, is that they were soft-shelled. Amniotes, the group that includes birds, mammals, and reptiles, produce eggs with an inner membrane or amnion that helps to prevent the embryo from drying out. The evolution of these calcified eggs, which offer increased protection against environmental stress, represents a milestone in the history of the amniotes, as it likely contributed to reproductive success and so the spread and diversification of this group. Soft-shelled eggs rarely preserve in the fossil record, which makes it difficult to study the transition from soft to hard shells. Associated with most of these embryos, which have their backbones and limbs flexed, consistent with the position the animals would assume while growing inside of the egg, is a diffuse black and white egg-shaped halo that obscures some of the skeleton. In contrast, 2 potentially hatched Protoceratops newborns in the specimen are largely free of the mineral halos. When they took a closer look at these halos with a petrographic microscope and chemically characterized the egg samples with high-resolution in situ Raman microspectroscopy, the researchers found chemically altered residues of the proteinaceous eggshell membrane that makes up the innermost eggshell. The same was true for the Mussaurus specimen. And when they compared the molecular biomineralization signature of the dinosaur eggs with eggshell data from other animals, including lizards, crocodiles, birds, and turtles, they determined that the Protoceratops and Mussaurus eggs were indeed non-biomineralized, and, therefore, leathery and dense. It's an exceptional claim, so we need exceptional data, said study author and Yale graduate student Jasmina Wiemann. We had to come up with a brand new proxy to be sure that what we were seeing was how the eggs were in life, and not just a result of some strange fossilization effect. We now have a new method that can be applied to all other sorts of questions, as well as unambiguous evidence that complements the morphological and histological case for soft-shelled eggs in these animals. With data on the chemical composition and mechanical properties of eggshells from 112 oth. From an evolutionary perspective, this makes much more sense than previous hypotheses, since we've known for a while that the ancestral egg of all amniotes was soft, said study author and Yale graduate student Matteo Fabbri. Thanks for watching. Do you like my video? Then show me your love by pressing like button. Please subscribe my channel and hit bell icon for new science inventions in future.